Hi, Lab 2 showed you how to filter patient data and subscribe to the data simulator. In this video, I'll go over the instructions for doing this in more detail. If you got everything in Lab 2 working, feel free to skip this video. In this lab, you will be doing your development in the coding cell under the Lab 2 heading. Before you begin this lab, you should have a completed version of Lab 1 copied and pasted into the cell. If you did not finish Lab 1, you can copy the code from the Course Solutions notebook. You'll begin by adding a filter function in between the source and sync operators. The new stream will be called heart rate. You will be writing a lambda function to filter your data shortly. Before you try to write this function, take a look again at the sample patient data. Different types of patient data are identified by a field called code. Notice that it's in a list reading type, which is in turn a sublist in the list reading. All heart rate readings have the same code, 88674. Knowing this information, you can write a simple lambda function to filter out all other types of readings. This function can be passed directly into the filter operation. It will take as input one tuple from your stream and output true only if it has the code value 88674. You'll have to change the patient data stream to the heart rate stream for the print statement. Finally, you'll submit your application over Bluemix. This part doesn't change from the first lab, so you can leave it as is. Run your application. Let's go to Streams console to see its output. Navigating once again to the log viewer, selecting the PE for your application, and loading the console log messages, you'll be able to see the output of your application. Upon closer inspection, you'll notice that it looks the exact same as in the first lab. This is because you cloned sample data that was of the heart rate type to produce all these tuples. In order to see the filter's effect more clearly, you'll need to subscribe to the patient simulator, which creates a diversity of reading types. Cancel your job by selecting it and clicking Cancel Jobs. This leaves the Stream console clear for the next step. Next, you'll submit the patient data simulator to the Streams console. Going back to the course notebook, you'll find a URL for the patient simulator. Copy the URL. To start the simulator on your Streams instance, you'll have to submit it from the Streams console. Click Submit Job. You can choose to upload a SAB file from a local source, or else specify the URL of a SAB file. You'll specify the URL as the one provided in the notebook. Click OK. You should now see a job with a name looking like this. This is the patient simulator. Now that that's working, let's go back to your application on the course notebook. The patient simulator publishes data to a topic. Your application will subscribe to this data. Replace the source invocation with a subscribe one. As parameters, you'll need the topic to subscribe to, which is ingest beacon, and the schema type, which is schema.commonschema.json. With your data coming from the simulator, you'll no longer need the observations function. You can delete it if you'd like. You can now submit your application over Bluemix and run the cell. Back to Streams console output. The log viewer is now showing two different jobs, the patient simulator that we submitted earlier and your application. Observe the output of the patient simulator and take note of the differences between tuples. The simulator is putting out readings of different values and of several different types. Compare this to your application's output. All tuples here have the same unit of measure, beats per minute, and the same reading type code. The only difference is the values of the individual readings as your patient's heart rate fluctuates. Your application is now selecting important tuples out of a greater diversity of data. It's looking more and more like a real application. That's all for this lab. In the next one, you'll transform and manipulate your data.